Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? All right, warm-up 32's on the screen. Let's get started, please. Today's going to go super fast. Once you're done with your warm-up, get 2 or 3 graphing papers. Today we're going to wrap this up with all the transformations we've been doing. Natalia, does anybody sit right there? Who? Alexa, all right. Jacob, does anybody sit in front of you? No? There you go. All right. Just to make sure we got this warm-up by now, being that it's Thursday. Am I right? Am I right? Okay. Be nice. All right, so number 1, here he goes. Before I go over number 1, check with your neighbor, see what they got for number 1, see if they have something similar to you. All right. Here we go. First things first, what do we check for to see if it's equal to a negative? Is it equal to a negative? No, so that means there is a solution. Second, is the absolute value by itself on one of the sides? Yes, Mr. Q. So therefore, you do 2 arrows, because we need to make the 5 into a negative, and the other one is going to be the positive. So -5 and +5. Okay. Now that we have our 2 numbers, we put our equal sign for each of those. And what do we use for our equation? Whatever's inside of the absolute value. What's inside? X minus 1, X minus 1. And now that we have our 2 equations, do we know how to solve those? Yes. +1 plus 1, X equals -4. This one, +1 plus 1, X equals 6. Hands if you got that by yourself. All right, not bad. How do we write that in set notation? Solution set of -4, comma 6. Close your set notation. That's our solution. Graph. Let me get my line here. Here's 0. Then we got 1, ... all the way to 6. Then I got -1 all the way down to what? -4. And all you have to do is plot your points for the solution. -4 and +6. Hands, have you got that by yourself? All right, not bad, some of us. All right, let me go to number 2. Number 2, factor. Question. Is there a number that divides 4, that divides 13, that divides 3? No. So, what number goes on top? Well, what is 4 times 3? 12. What number goes underneath? 13. So what 2 numbers multiply to give me 12 that when you add them give us 13? 1 times 12. Is that correct? 1 times 12 is 12. 1 plus 12 is 13. However, since we have the 4 in the front of this trinomial, we write that above each of these numbers. So question, can I simplify this fraction anymore? No. It's already in simplest terms, so my factor for that one is 4x plus 1. We know that this is for the x, and this is for the number. Next, can we simplify this fraction anymore? Yeah, divide by 4, right? So we end up with 1 over 3. So what is my factor for that one? X plus 3. These are my factors. We good? Yes, Mr. Q, I love these. All right, good. All right, let's go to number 3. Number 3, inverses. By now, you should be able to do that one in your sleep. So, check with your neighbor what you get for the inverse for those two. Then I'm going to have someone help us out with the process for one of them, just to go through the process one more time. Check with your neighbor. Looks like Allison's done. Very good, Allison. All right. However, let's go with Scarlett. Help us with 1A. What is my first step? So switch fx to y, so we end up with y equals 3x minus 5. Ooh, Scarlett in the house. Plus 5, plus 5. She reminds me of being in kindergarten. Let's go. So we got y plus 5 equals 3x, and then? She lives in the middle of the problem. No, you're good. Ooh, divide by 3, divide by 3. So we end up with y plus 5 over 3 equals x. She's all confident. She's like, I got this. Walking to get my graph paper, and then I'll give you the results. Everyone, is this the inverse? No, we swap the variables. All we do is exchange them, so we end up with x plus 5 over 3 equals y. There's no magic thing that we do. But do we leave it in y form? No, Mr. Q. X plus 5 over 3 equals f of x, but with our little inverse sign. All right, not bad, not bad. Hands if you got that by yourself. All right, good. Let's go to 1B. Check with your neighbor, see what you got for that one. Then Scarlett's going to pass it to someone so they can help us with the process. All right, good conversation. Scarlett, pass someone. Gio, go. Oh, Leo, okay. Leo, go. Oh, Gio, go. That was good. All right, Leo. And then? Before that? If the 4 is multiplying, the inverse is 2. Divide by 4 both sides. Very good. We end up with y over 4 equals x cubed. And now what did you say we were going to do? Cube root. Cube root. This cancels that. We're left with cube root of y over 4 equals x. And then? Swap the y and the x, so we end up with cube root x over 4 equals y, and of course we need a function notation, f inverse x. And if you got that by yourself, all right, not bad, not bad. Look how beautiful that looks. Some t-shirts, right? There you go. On my YouTube channel, there you go. All right, let's go to number 4. Number 4. Graph f of x equals x squared. Now, by now, we should be experts at that, yeah? All right, tell your neighbor the 5 points to graph that one without a table. 5 points. What are my 5 points? All right, 5 points. Pass someone, Gio. All right, Leo. Gio, 5 points. 0, 0. 1, 1, negative 1, 1. Negative 2, 4. And 2, 4. Okay. All right, we got that. But they're asking us to transform according to this. So let me write my form, g of x equals a times f, x minus h plus k. And of course, we do that without the parameters a, without the h, and without the k. So, what is a? A is -1. H is -5. Put the little square here for the quadratic. And k is 4. So my new form is g of x equals -1. Do I need to write the 1? No, I'm just going to leave it as a negative. F x negative times the negative is a positive 5 squared plus 4. So, for anything, tell your neighbor where we're going to move those 5 points according to that. Where are we going to move the 5 points? Tell your neighbor, please. All right, let's go with Miguel. Where are we going to move the 5 points to? 5 to the left. And 4 up. Hands, have you got that? Yes? All right, however, before we do, tell your neighbor what this does to all the points. Tell your neighbor, what does that do to all the points? Miguel, pass them one. Leo, what does that do to the entire function? It flips it. That is correct. So we got this point, this point, this point, this one down here, this one down here, and now we can move them 5 to the left and 4 up. 5 to the left, 4 up. So our new function is going to be somewhere up here. And we label that g of x. Hands if you got that by yourself. All right, some of us. All right, good. Last but not least, number 5. There it goes. Question. What is GCF for the top 2 terms? What divides 2x? That divides 8. Everyone, what divides 2x? That divides 8. 2, parentheses. So 2x divided by 2 leaves us with x. 8 divided by 2 leaves us with 4. All right, let me zoom into that. Next, what is GCF for the denominator? What do both of these have in common? An x, that is correct. So if we took out an x from here, we're left with x. If you took out the x from there, we're left with 4. Question, do you guys see a giant 1? You don't see a giant 1? What is it? Bx plus 4, that is correct. And why can't we take the whole thing out? Because there's multiplication here with the 2 and multiplication with the x. So what does that leave us with? 2 over x. Once again, I'm bringing these in because we're about to get into that concept in a couple of weeks. So I'm trying to give you guys some practice before we get there. Thank you, Mr. Q. You're welcome. I got you. All right. Send me your warm-up, please. I want to see what you did.